Hello everyone, welcome back to Magad Gyan Kendra, and in this video we'll be discussing about work and energy. This would be the first part of the topic work and energy. So let's begin. So let's start off with an example. So suppose you were sitting down and just studying, and a physicist comes up to you and says, "Hey man, why are you not doing any work?" And you are like, "What is this man talking about? I'm studying really hard, I'm concentrating at my studies." And the physicist says, "You are not doing any work, you're not applying any force, or you're not displacing anything." So let's see why you were not doing any work while you were studying. If we talk about common logic, then you would say, "I was doing a work while I was studying," but according to science or physics, you were not doing any work. This is because work is said to be done in physics. Work is said to be done when an object applies a force and it displaces the other object. Meaning, if a force is applied and the object on which the force was applied moves, is known as work. We saw right now was that work is said to be done when force is applied and body displaces, which means work is represented by W. Work is equal to force multiplied by the displacement, also can also be written as Fs. Work is equal to force into displacement. Now in this case we will see what is the unit of work. So we know that the unit of force is Newton and the unit of displacement is meter. So that means the SI unit of work would be Newton meters. So instead of writing Newton meters, we instead write joules. So work's SI unit is joule. Work is a scalar quantity and is only has magnitude. It does not depend on direction. So there are some examples of work, some common examples. So for example, you were pushing a wall. So you were applying force on the wall, but there was no displacement. So what is happening? Suppose you were applying a force of 5 newtons on the wall. So work done would be 5 newtons. But when you were applying a force on the wall did not move. So the displacement was of 0 meters, which results in 0 Newton meters. So work done is 0 Newton meters or 0 joule. So no work was done when the body did not displace. And the other example is when so this was when work is 0. Other example can be when work is non-zero. So work can be non-zero. So for example, you were pushing a light box by applying a force of 10 newtons and it moved a distance of 5 meters. So the work done would be 50 Newton meters or 50 joules. The work done would be in that case 50 joules. Now let's see an example in which work can be negative. Work can also be negative, but still work is a scalar quantity. Remember that work can be negative, positive or 0, but it is still a scalar quantity. It is not a vector quantity. Work can be negative in many cases. So let's assume the gravity. So gravity applies a force as well. Gravity was applying force, but you were pulling a block. So for example, you were pulling a block upwards, you were lifting a block, but we are not considering your force done on the block, we are considering the force done by gravity. So imagine some X force was done on the being done by gravity on the block, and it was displacing in the negative direction. The force of gravity was in downwards direction, force of gravity. So let's assume this box. The force of gravity was in this direction, but you were lifting the box in this direction, which means the object moved in the opposite direction towards the force. So when this happens, when the displacement is in the opposite direction of the force, then the work done is negative. Work done would be negative. It would be in negative value. So this was all for this part. In the next part, we'll be seeing why work is scalar quantity, but still work can be negative, positive or 0. Make sure to subscribe to our channel.